7. Okay, let me do it this way. All right, so we're back in high school. You guys did something like this, right? No? Well, without the A and B, I mean, it would be something more closer to like this, right? Because what does that mean? That means that that's what you would have, right? And back in high school, that's exactly what you would do, right? So back in the high school, that's what you would do. Well, here in college, so number one, this is called open interval. The reason why it's an open interval is because it's open on both ends. Unlike myself. Here in college, we don't use that notation, that inequality notation. We actually use an interval notation. And that would be parentheses, -2, comma 3, close parentheses. That looks more familiar? And we wouldn't use open circles, we would use parentheses as well. So instead of using -2 and -3, I just use A and B instead, right? That's what I did. Does that make sense? Questions? No? Okay. Oops. I guess I should have done these two too, right? So what if I did this instead? What happens now? Circles are closed. If it's closed on both ends, what would that be called? Since both ends were open, we call it open interval. Since both ends are closed, we're going to call it a closed interval. And what we write, how would we write this in an interval notation? Square brackets. There we go. Okay. So let me ask you guys this. What if I don't want it to be open or closed? but I want it to be half open or half, not half closed. What would that mean? See? Like that, you mean? And like that. And then like that. Now, guys, both of these could be considered as half open or half closed. Don't look at one as, oh, that is half open because it, the right side is open versus closed means the right side is closed. Don't think that way. These are both half open or half closed. Got it? It just doesn't tell you. There's no specification on which half has to be open or closed to be called half open, half closed. Bless you. I'm gonna pause. You guys got all of that, right?
How's she doing?
She's doing great. Old family friends are coming into town, and they're like, "Oh yeah, could you come home early and have dinner with us?" No, mom. I actually have to work, and she has no idea that I'm teaching right this second. So, huh? That's the way it goes with moms and dads. All right, so here's the thing. What if there is no end, right? So we could have this versus and versus, right? All of these are possibilities as well, right? So how would I write these in interval notation? So this one will go from negative infinity to a, parentheses on both ends. This will have a square bracket on the a, right? And this will go to infinity, while this, oopsies, will have a square bracket on the a. Now, don't get me wrong. If my house was only like 5 minutes away from here, it'd be okay. What is that? It's a good 45 minutes to an hour away. All right. So, what if I had these inequalities? So, how would I solve? So, solve the same way as a regular equation, except Flip the inequality when you multiply or divide by a negative. Now, notice I said multiply or divide by a negative. I did not say if it is a negative. Multiply or divide by a negative. Got it? Let's do an example. So the problem is that you might have things that are going to be just single like this. Yes? With this what? Says what? Oh. It's okay. There you go. Except if you F up the inequality. If you F up the inequality, so you might have inequality that have one inequality in it. You can have some that has double inequalities in it. Okay. So if we only have one, solve it as a regular equation. I would still get x by itself here, right? So I would subtract the 2. And then because I'm dividing by a -8, yeah. You just flip it the inequality. Now here's the thing. You can avoid this mess if you wanted to. You can avoid this mess by going, okay, I'm not going to divide by -8. That means I want my x value to be positive, so I'm going to add the 8 over to the other side, right? I can add the 8x to the other side. And then subtract the 18. And then divide the 8. I can avoid that whole thing if I wanted to. Now, I do want you to see this. These two answers mean exactly the same thing. So we bring you back to grade school. They'll, they always say, oh, if they're going to eat the bigger fish, right? Or the fish is going to eat the bigger number, right? So over here, this is eating the x. This is also eating the x. Okay? So, and I know that you guys want to get the x on the left-hand side all the time. So if you just take the mirror image of this one here, you will see it looks exactly like this. You guys are remembering that story from grade school? Eating the bigger number. Now, you, however, could have something like this. Oh, wait a minute. Let me finish the other one off here. Sorry. So to finish this part off, since I know as x is greater than or equal to -2, my answer is what? How do I write this in interval notation? Sorry. Right? Because everything that's greater than or equal to 2. So that means it's going to be going towards infinity. But it touches negative, is including -2. So that's why it has to be a square bracket on -2. So here, you might have it where you're going to have 2 inequalities here. So how would I solve this one? So my past students are going to ask me, hey, do the sisters still work here? And the current students are going, I have no idea what the sisters are. So the sisters is what I use to get common denominators in a fraction. Okay. So here, if we were to look at this, if we can get all the denominators the same, then we can get rid of them in an equation, in this case, inequality. So if we only focus on just the denominator, the 3, the 4, and the 3, and get them to be the same, we usually say, what do they have that I don't have? I know with 3 and 4, you guys can figure that out pretty easily. So this one is missing a 4. So whatever I multiply to the top, I mean bottom, I have to multiply by to the top. This needs a 3. This needs a 4. So what I'll have is a 4 over 12 is 3 times x plus 1 over 12, 8 over 12. So from here, since the denominator is exactly the same, I can drop them. So I'm left with the 4 is less than or equal to 3x plus 3, which is less than 8. So from here, whatever I do from the center, I have to do on the other sides as well. Okay. Yes. By 12, yes. But then you'll have a fraction on the wing, on the end, right? You could do it. Yeah, you can do that. You can definitely do that. But here's the thing: most students don't like any fractions anywhere. They'll only deal with it if they have to, right? So here, I would subtract 3. So if I subtract 3 here, I have to do it on both ends as well. And if I divide, I have to divide the other ends as well. And yes, if I divide here by negative, both the signs would have to flip as well. So how do I write this in interval notation? Or this, yes. So what she's saying is absolutely right. It's not wrong, right? So I used to teach this differently. I used to teach this as create 2 separate equations. or two separate inequalities, and solve those inequalities separately. And then graph them to see if they actually meet together or point away from each other. Okay. So the one thing that you're going to need to know is this. When you look at an inequality and you see this right here, which is some type of less than sign, and this is also some type of less than sign, that means they are going to be connected with each other. Okay. And then what's going to happen is that if it goes the other way, which we're going to talk about in absolute values, we will talk about in absolute values, right? If it points the other way, well, I shouldn't say that. I should say sometimes when it points the other way, it will point away from each other. And you will see that in absolute values. And yes, there is absolute value inequalities coming up. Yes. Mm-hmm. All right. So absolute value inequalities. Shoot. So when you guys look at this, this is going to apply to the less than, equal to, or versus the greater than or greater than equal to. Okay. It applies to the same thing. So what she was just mentioning, this is where this kind of comes into play, because that's the way I used to teach it as well. So the way we would deal with this is that when it's less than or equal to, we would say that the U, the inside, is less than A, and the inside U is greater than negative A. So we're still doing the positive of the other side and the negative of the other side. But remember, when we get the negative of the other side, we had to divide by a negative, right? Or multiply by a negative. So that's why the sign flips. Everybody see that? Well, the reason why it's an and that's exactly what she did. She unioned the two intervals. Well, the union of the two intervals would give you this. That's why she says like, or you can just put them together, right? That's exactly what she said. So if I had to deal with the less or equal to sign, I just do that. I know, very, very complicated, right? But it makes sense. So I'm still using the other side equal to the positive of that side, and the inside equaling to the negative of the other side, but the sign would flip. The inequality would flip because it's now the negative. So it's kind of like multiplying by a negative, so I flip the inequality. So if that's the case, let's look at the other side. The other side, the inside would be greater than the positive, and the inside would be what? Less than the negative, right? Because I have to flip the inequality because it's a negative. Except this is not an and. This is going to be an or. Can you guys picture why this is an or and not an and? Okay. So let's pick an A. 3? Is 3 a good number? Okay. So let's use X as well. So X is greater than 3. Okay. So again, sidebar right now. So I'm going to write down X is greater than 3 and X is less than negative 3, right? Okay. What way does X is greater than 3 going to point? Is it going to be open circle pointed that way, right? Okay, great. Let's look at the other one. It says X is less than negative 3. What is that going to look like? Open circle pointed that way, right? Do these 2 points meet each other at all? Do those 2 lines meet each other at all? No. That's why it's an or. It's either this side or this side, nothing in here. Make sense? Now let's look at the and. Let's use X is less than 3 and X is greater than negative 3. Okay. Let's take a look at that. X is less than 3. Open circle, pointed which way? That way, right? X is greater than negative 3. So why was the 3 pointed that way? It says X is less than 3. So wouldn't it be open circle pointed that way? And negative and X is greater than negative 3, wouldn't it be open circle pointed that way? Are they going to meet each other? Are they going to cross each other? That's why it's an and. Because they are going to have common or intersections of each other. Does that make sense? Yes? Like, yeah, great. Okay. That's the only reason why it's an and versus an or. So here's what the OR would look like. And here's what the AND would look like. For some reason, I almost thought that was thunder. And wow, that's a long time. This keeps on going. Are we okay or no? Now, here's where my suggestion is going to be. My suggestion to you will be to work at it as two separate inequalities and graph them. If they do this, then you know what to do. If they do this, then you know what you need to do. Make sense? So to me, I wouldn't stress over, is it less than I write this equation? Well, it's a greater than, I'll write this equation. You can remember that if you want to. It does make the math easier, but do you have to make the math easier necessarily to remember something? No. The question is, how does your brain think and how can your brain remember? Okay. So let's jump into an example. What do I gotta do? And then like that. Are we okay there? That all makes sense? You guys see that? Should I separate those two? Are we okay there? That makes a lot of sense. Okay. Now, anytime that happens, it tells me that my result is really from here to here with parentheses. You really only need this purple. You don't really need the red and blue. The red and the blue is to get me to verify that it is together. So it's either this right here, which will help me get this. Does that make sense? Which would be my answer. Right? It is more steps, but I'm getting still to the right place. Does that make sense? Questions? Ask your questions. You're either going to have it now or you're going to have it later. You might as well give it to me now. This part, you're taking the inside and setting equal to, so essentially, the equation on the left looks something like this. The one on the right will be the inside equaling to the negative of the other side, right? So when I negate the other side, I have to flip this inequality because it's a negative. Just like I did absolute value up here. Where is it? Right? Where I took the inside. Wait for it. There it is. Right? I took the inside, set it equal to the positive, and set the inside equal to the negative. Okay? So because the inside could be +3 or -3 in this case, so I do the same thing here. The inside equal to the positive and the inside equal to the negative. But because it's negative, I have to flip the inequality. This has to flip when I do the negative. Always. Okay. Or you can think of it as like flip, flip, because I didn't just flip this, I also flipped this sign too, right? So I flip this sign and flip this sign. Correct. Correct. Now, you guys could so the other thing you guys could look at is this. So let's say we have the same exact problem here. Literally the same exact problem. What you guys could remember if you wanted to is remembering that this is a less than sign. Less than or less than or equal to sign. Okay? And because you know that this is a and. Okay? And because you know that that is an and, then you would take the inside. So you're writing the same exact equation, but because it's an and, you write the other side. You could do it that way. Everybody see that? Now with the or, you have to write the 2. With the and, you can write it as 1. Whoa. Does that make sense though? What's the matter? So because there's a less than sign, I can write the and. So that means I have to have the positive 3 and the negative 3, right? Well, the positive 3 is clearly right here, and the negative clearly has to be less than 3, right? That's why I wrote the negative 3 here, right? So, and these two symbols are also going to have to be less than signs. So these three symbols will match together. You guys see that? Okay. So again, this will match here, symbol wise, and will match here, symbol wise. And when I write the negative of this, it's going to be in front because negative is going to be less than the positive. Right? Okay. So again, if we solve this, then we would just add 4, right? Which is exactly what we had as an answer. Make sense? Don't give me the look of I want to punch you in the face. Questions? None? All right, fine. I'll give you this example then. I will. Come on now. Come on now. Give me a little more credit than that. Are we done yet? We should be. Why should we be done? Does that make sense? Now it does. Did it make sense? Right? So that's the thing that we gotta notice, right? So remember I said this right here. I said that we would write this right side as is. And we gotta write the negative, right? And since the negative is definitely less than the positive, we will write it on this side. So when you start writing this one, you're like, okay, I gotta write as is. Got it. 7x plus 8 is less than -3. Great. I do this. Well, 3 is not less than -3. Or do I do this? That doesn't even make sense. See what I'm saying? So that's the reason I'm writing it this way makes it easier. Right? Remembering that makes it easier. But not necessarily only way. There is other ways to make it happen. So as requested, oh, by the way, let me show you something else. If I wrote this, copied this down, let me show you something else. I said to you guys that the -3 is less than the 3. That's why it's on the left-hand side, right? So look at this. If I was to choose, dang it. Does that inequality make sense? Because it says -3 is less than 3, doesn't it? And that makes sense, yes? And it doesn't matter if I use this one or, oh gosh, how am I going to do that? Or that one, right? It doesn't matter which inequality I choose, it still tells me the same thing, doesn't it? That -3 is less than 3. That's the reason why I know for sure it works. It's definitely an and. Okay, so let's take a look at this one right here. Right? So let's say you go, okay, let me write this as is. Right? Okay. Maybe this is an and. So okay, I'm gonna write this side, symbols are the same, and it's gonna be negative, right? You write that. Okay. Is that a true statement? No. -5 is not greater than or equal to 5. Oops. I can use the other symbol, but the other symbol is going to give me the same freaking thing, right? That doesn't make sense. Everybody see that? So once I start writing that, and that part doesn't make sense, I already know it cannot be an and, it has to be an or. It cannot be an and, it has to be an or. Everybody see that? So you can try to write every single time an and going, that doesn't make sense. It has to be an or. So then you can go, okay, let me erase this. And now I have to write down the inside, flip the sign, flip the inequality, and flip this sign to be a -5. It definitely has to be an or. Fair enough? I think that would be probably the best way to kind of figure out if it's an and or, right? Let's just assume it's an and let those inequalities tell me it's a totally an or. Okay? Because that was a dead giveaway. That's definitely an or. All right, so let's solve. Actually, let me change this to bleu. Okay, because again, remember how I said in the beginning with absolute values, the inside can be the positive, can be that 5, and the inside could be the negative of that 5, because if I take the absolute value of 5, I get 5, right? If I take the absolute value of -5, it can also equal to 5. Is that right? Okay, so that means my inside can either be +5 or -5. That's why I have the 5 and -5. Correct. Because it's like multiplying by a negative, so therefore flip the sign. Are we okay with that? Is she okay with that? Yeah. How would you? Well, you have this, right? You have that x is less than or equal to -1 and x is greater than or equal to 9, right? It can't be the intersect. Because what's the intersect? Things that are in common, but there's nothing in common. So I guess I would do, dang it. Because it's that solution and that solution. Okay. Any other questions on that? Yes. It has to be the U. I know it should be like separate answers. That's what you're thinking, right? It's this answer and this answer. Well, okay. How about I put it this way? The comma says it's one or the other. The union says it's both, right? And it really is. It's this interval and this interval together. These are all solutions. Not this could be a solution and this can be a solution. Kind of like when we do factoring, right? It's one or the other, so there's why it's a comma for that reason. Okay. All right. So it's something, well, I'll just put down 2.1. Any other questions, by the way, before I continue on? You seem so mad at me. Stop being mad at me. Not you. The angry one.